In our previous video, we looked at an introduction to pointers and pointer basics. Here we have a very simple program just to demonstrate using pointers once again. However, I want to look at what happens if you set the value of your pointer to the reference of another pointer. So if you look up at our top, you'll see that we initialize x and y, and a pointer to x and a pointer to y called px and py. Those are all set and initialized correctly. And we'll print both the x and y values as well as the reference to the pointer x and the pointer y. However, then we set px equal to py. And people might be a little confused about what's really going on there. So let's run this real quick and take a look. So if we look at our output, we see that x is 5 and y is 10, and we see the memory address for x and y. Then we set px equal to py, and notice that x and y stay the same value. However, px and py now point to the same memory location. And that's the memory location for y, so they both are dereferencing to y and 10. This can get a little bit confusing because, well, number one, I could wind up having two pointers pointing to the same memory address and not realize that one is making a change. That's just one example of a bug that could creep in, and I could have others that would go through a normal process as well. So a quick and easy way to fix this is to use the const keyword. Remember, const is going to set something to be constant. And so what I'm going to do is I'm going to put in front of my declaration for px and py the const keyword, and you'll notice that it's going to give me an error immediately when I try to set px equal to py. Now I don't have to put on both, only the ones that I want to make sure don't get updated. So I'm going to comment out my line of code that would generate an error, and I'm going to show you how important this is and the difference between setting a const on a regular variable versus a pointer variable. Px and py both are pointing to memory addresses, but the variable px is pointing to memory address for variable x. And if I set variable x equal to 7, for example, notice it's not showing me an error. And if I go and run this, you'll notice that I can still change the value at that memory address. I just can't change the memory address that px is pointing to. And that's how you use the const keyword to keep a pointer from changing its memory address that it's pointing to.